All right, this is the fourth and final way to solve quadratics, and that's by using the quadratic formula. This method becomes really helpful in Algebra 2 because as we've been able to get no solution for some of our problems here in Algebra 1, you won't in Algebra 2. The quadratic formula allows you to get an answer even when there's no solution. We won't worry about those kind here in Algebra 1, but just so you know, this will come back in Algebra 2. All right, this one really you can only think solutions. It is like the most broad way to be able to find solutions. Now the formula is kind of intimidating. Don't be intimidated by it. Really what we're doing today is basically PEMDAS on steroids. It's gonna look a little crazy, feel a little crazy, but it really breaks down pretty quickly. So the formula looks like this. It says negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Whoa. So really this plus or minus tells you that there's technically two versions of the formula, one where you add the square root and one where you subtract it. But again, mathematicians are lazy, so we kind of combine them into plus or minus, and it's written in one big formula. Eventually, as we're solving and using it, we're going to have to split it apart and do one addition and one subtraction version. But we'll do that once we get it a little smaller than it is right now. So here are things that you need to know about that formula. A, B, and C seem like random variables, but they're really just the coefficients from your equation. So if you remember back to ax squared plus bx plus c from factoring, that's where those numbers come from. This number, whatever it is going to be a, this number will be b, and this number is going to be c. When you grab a, b, and c, do not grab the x's with it. What will happen is you're going to end up with x's underneath this square root down in this denominator, and you don't know how to handle that, and that's okay. Don't make it too complicated. We just want the numbers. It is a good idea if you have minuses in here to make those numbers negative, and we'll see that in some of the examples later. Other things that usually come up when they give you this formula is that it says that a is not allowed to equal 0. So this front number can't be 0, meaning that this term would be gone. So it does a couple of things. You also have a down here in the denominator and an a here. This one is less affected by that. But if a is in the denominator, if a equaled 0, your whole denominator would equal 0. And so it basically tells you this, and it's things you already know, because you can't divide by 0. And this can't work on linear equations. All right, if we got rid of this x squared, then it would look more like mx plus b, and this isn't meant for that. It's called the quadratic formula for a reason, not the linear formula. All right, the other thing that it'll often tell you is b squared minus 4ac has to be greater than or equal to 0. So notice where the b squared minus 4ac chunk is. It's underneath that square root. All this is telling you is that you have to square root positive numbers. Here in Algebra 1, we won't square root negative numbers, but in Algebra 2, you could. So they kind of remove this little rule, but we're going to only square root positive numbers. Okay, so typically you can still have 2, 1, or no solution. Most often with the quadratic formula, you're going to get 2 solutions. No solution for us would happen if we get a negative underneath of that square root. 1 solution would happen if we end up with the same answer after we split it for both little chunks. But again, most of the time it's just going to end up being 2. All right, so here's what we need to do to make this happen. We're going to make the equation equal to 0 first, or it is allowed to have y equals. That's okay too. Then after that, we need to know what a, b, and c are, so we're going to grab those from our equation. Again, just looking at the number pieces. And then ultimately, we're going to plug those values into our quadratic formula and simplify. So again, you're thinking like mega PEMDAS, lots going on. Again, you can still have 2, 1, or no solution. Most of the time it'll be 2. And fractions are a normal thing. You will often get a whole number answer and a fractional answer. Sometimes both fractions, sometimes some weird decimals, and we're going to go through kind of one of each, where we get something normal, something with some fractions, and something with some really wonky decimals. Okay, so ready, here we go. So my first step is to make sure that it equals 0, which in this case it does. Very cool. We need to grab a, b, and c from our equation. So remember, there is a number right here. It should be a 1. And that 1 is actually going to be a. Okay, b is our next number. So in this case, -3, do include the sign. C is going to be -40. Okay, so just grabbing 1, -3, -40, A, B, C, right in order. So now I'm going to plug these into the formula. I'm going to try to use two different colors. I'll keep my numbers that I'm plugging in blue, but I'm going to put the parts of the formula in red. So that first negative symbol comes from the formula. Make sure that you use parentheses. It can cause problems if you don't. So b is -3 plus or minus the square root of b squared minus 4 times a times c, and all of that is going to be divided by 2 from the formula. A. Shoo. That looks really crazy, and it does look a little intimidating, but it will fall apart pretty quickly. I'm going to go ahead and start combining what I can combine, and a lot of stuff happens underneath of this square root, so that way it'll get a lot smaller here in this first step. So -3 here to start turns into +3. The plus or minus sticks around. We can't do anything with that just yet, not until we've simplified everything else we can simplify. -3 squared is +9. Do make sure that if you have a negative there, that gets in parentheses. That should end up at a positive number after you've squared. Then I'm going to do -4 times 1 times -40, which should be a +160. And then down here in the denominator, 2 times 1 should make 2. So it's looking a lot better already. Most of the work, again, is going to happen with the square root first. Division will always happen last, and is the very last thing that we do in our problem. Okay, so I'm going to combine the 9 and the 160 to make 169 first. We're going to divide that by 2. So now I can actually take the square root. So if you think back to our square root lesson, how it had 2 answers, the square root of 169 is 13. This actually takes care of the 2 answers for you. It has the plus the 13 and the minus 13. It looks like square root symbol. All right, and at this point, this is where we're going to have to split it. I can't do plus and minus at the same time. So what's going to happen is I'm going to make a version where I have 3 plus the square root of 13. We're using this piece right here. So 3 plus the square root of 13 divided by 2. And we're also going to make one that's minus. So 3 minus 13 divided by 2. Once I simplify each of these little pieces, we'll be at our answers, which is really cool. So on this one, 3 plus 13 is going to make 16. And 16 divided by 2, that division goes last, is going to make 8. As I simplify this branch, 3 minus 13 is -10. And -10 divided by 2 is going to make -5. So that makes these two pieces my answers. I'm going to have x equals 8 and -5. Super cool. I know it's a lot of work. And I'm sorry about that. Just is what it is. Okay, next one does not equal 0 first, so I am going to have to make sure that that happens. After that, the process is really the same. So I'm going to have 2x squared plus x minus 10 equals 0. Once it equals 0, then you're good to go. Okay, do remember that there is a 1 in there that you're going to use for one of your letters. So on this one, a is 2, b is 1, c is -10. All right, as I plug things in, okay, I'm going to have negative b plus or minus the square root of b squared. Oops, squared comes from the formula. Minus 4 times a times c all over 2a. Okay, looks like that. All right, so we're ready to start simplifying. So negative 1, we'll make negative 1. Plus or minus sticks around until it's time to split. 1 squared is 1. Then we have negative 4 times 2 times negative 10. That's going to make 80. And down here on the bottom, 2 times 2 will make 4. All right, I'm going to keep the negative 1. We're going to add underneath the square root. 1 plus 80 will make 81. I'm going to square root 81. Should make 9. And again, my formula itself takes care of the 2 square root answers like we had in the last section. Here's the positive 9 and the negative 9. Which, speaking of which, it's time to split. So I'm going to have one that's negative 1 plus 9 divided by 4, and one that's negative 1 minus 9 divided by 4. This one's pretty typical in that after I simplify this, it'll give me 8 divided by 4, which will make 2. So it has one whole number answer. And the other one down here will make negative 10 divided by 4, which will be some sort of decimal or fraction. So you can reduce, should make negative 5 over 2 or negative 2.5. Either one is okay. So I like fractions personally, so I'm going to stick with the fraction on this one. So I'll have 2 and negative 5 over 2. All right, so this next one is going to give us double fractions, and that's also okay. Hopefully, if you're right, I'm going to skip the colors on this one and just kind of simplify for us. All right, so already equals 0, a equals 6, b equals negative 11, c is going to equal negative 10. All right, as I plug it in, so I'm going to have negative 11 plus or minus the square root of b squared minus 4 times a times c, all over 2a. Okay, filling in all those numbers, using parentheses everywhere, even if you feel like you don't need them, use them, they're important. So negative 11 makes positive 11. Negative 11 squared should make positive 121. Negative 4 times 6 times negative 10 is going to give me positive 240. And 2 times 6 on the bottom will make 12. It does fall apart pretty quickly. So we have 11 plus or minus. Under that square root, 121 plus 240 is going to make 361, which seems kind of big. If you're not sure what the square root of 361 is, go ahead and type in your calculator. And who knew, it actually is a perfect square. It gets 19 as its square root. So as I split it, I'm going to have 11 plus 19 divided by 12, and then 11 minus 19 divided by 12. So here, this one will make 30 divided by 12. And 30 divided by 12 makes 2.5 if you're thinking decimals. If you math enter that or switch that up in Desmos, it should make 5 over 2. Here, 11 minus 19 is going to make negative 8 divided by 12. It also gives you another decimal, in this case, negative 0.6 repeating. So I'm going to give those a few 6s and then the 7 on the end. You can also change that one into a decimal too. It should make negative 2/3. So if you prefer decimals, your answer probably is going to look something like x equals 2.5 and negative 0.6 repeating. Or if you're more of a fraction person like me, you might have something that looks like 5 over 2 and negative 2/3. So this is fine. So is this. Whatever floats your boat. All right, where it gets a little crazy is something like this, where you don't actually get a perfect square, but you do have a positive number under there, which means that it does have a square root. It's just not a nice, pretty whole number. This happens more in Algebra 2, but I just want to introduce it to you here just to make sure that you're familiar with what can happen. All right, so if I grab my A, B, and C first, A is 5, B is negative 9, C is 3. So as I plug those in, I'm going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's simplify. So we have 9, positive 9, because negative negative makes positive, plus or minus the square root of 81 minus 60 as I multiply all those together. And 2 times 5 on the bottom will make 10. This is where you can kind of tell that something's a little off, because you get 21 underneath of your square root. Now, part of the nice thing about quadratics is that occasionally what they'll do is they'll make this your final answer. They'll just have you split it. If you can't make that square root a nice number or something that actually works out, then you get this and this. And that's okay. Or sometimes what they'll do is they'll continue on and that will actually go ahead and do these chunks in the calculator. So what they'll do is they'll end up with some decimals. And so you actually get something like 1.3583 for the first one, and you'll get something like 0.4417, rounded a little bit, on the next one. So sometimes you'll see these as answer options, and that's okay. If you get the decimals, you can confirm by typing in those answer options and then seeing if you get the matching decimals, which we're going to show you how to make that work here using Desmos as well. Now the nice thing is that graphing method that I'm sure that you appreciated because it was pretty easy also kind of works here a little bit too. So I'm confirming some of these for you and I'll show you how they kind of work. So here's our very first example, the x squared minus 3x minus 40 equals 0. I already have it graphed for you. Okay, and if you look at those x-intercepts, they should help confirm your answers of 8 and negative 5. Okay, looking great. Now, if this part of your simplification is a little bit of a struggle for you, you can type the whole thing very carefully into Desmos. So right here is our graph of this particular equation. So you can see our solutions are correct. We have 2, and then we have negative 2.5. If you end up with something like that and you need the fraction version, you can hit that little toggle as well. But if you take a look here, I carefully typed it in. It's even so long that you can't even see the whole thing all at the same time. But you have to be very careful, make sure that you use parentheses, but Desmos can spit out that answer for you. You have to also do it twice. You need one version where there's a plus sign and one version where there's a minus sign to get each of those separate answers. It won't do the plus and minus together. All right, and again, so here's my positive version with the 2, just like we got, and then here the negative 2.5. And if I hit that little fraction toggle, it will tell me that that's negative 5 over 2, just like we got here as well. So you can confirm those as well by clicking on here to get that negative 2.5, and here, just to make sure that you've typed everything in correctly. You should be able to get the same answers as your graph. Okay, I did skip this one in Desmos, but I did put that last one, especially with those really weird wonky answers. Okay, so you can take a look. Go ahead and get that graph off of there. Here's the graph of our very last equation. Okay, it's kind of skinny and really close together. All right, and you can see those really kind of weird decimal x-intercepts. If these were the answer options that I got, I could find those decimal answers from the graph and then type in my answer options, the positive one and the negative one, to see if those decimals are a match, which in this case they are. This one has been rounded a little bit. You see 0.442. Here it's 0.4417, and that 7 would round up to 2. But it can help you confirm those weird wonky decimal answers just to make sure that you're confident in what you're doing and doing it correctly.